Dr. Burton, let's go back a bit. When you were at St. Vincent's, the American Cancer Society's science writer, Pat McGrady Sr., came by the hospital. He was a friend of Retino. He asked what was new, and Retino said that you had been able to develop a substance that, when injected into mice that had tumors, were able to shrink the tumors in a period of an hour. He wanted a demonstration. It was given. He was impressed, so impressed that he invited you and Dr. Friedman, one of the associates, to come to the American Cancer Society's annual Science Writers Conference in Phoenix, Arizona. There at that conference, before all the science writers, 2 mice were selected.
Oh, there were 8 of them.
8 of them?
8 of them.
But the injection was given. In a period of a couple hours, the tumor shrank before everyone's eyes. Correct?
Well, to a degree. It shortened down.
And then many of the science writers were very excited by this because nothing up to that point had been able to do that. And immediately, some of the leading oncologists started to say that this was just quackery. So McGrady said, all right, you take the ampules and you inject the mice. You select your own mice and inject them.
Oh, well,
they refused to do so?
I think it sounds a little different. McGrady was at St. Vincent's to get a stomach resection. While he was recuperating, he went through, and we were in just the beginning of injecting breast tumor mice. Now, we were studying in that time what occurs. We would anesthetize the mouse, inject the mouse, and then open up the body, pin it out, and watch what occurred. Well, Pat McGrady said, how often can you do this? Well, we said, we've done it about 50 times. Has it failed? I said, no. Would you put it on for the science writers? Yes, we went to Phoenix, Arizona. There, we injected 8 of the animals. We unblocked the animal's immune mechanism. Essentially, what we did is took out the blocking protein and gave the animal back what was present in its blood. The only thing added was a sodium-potassium buffer. Well, when this occurred, I know the Los Angeles Examiner had a headline, "The 10-minute cancer cure." Oh, big time. But a group of oncologists went to him and said it was a trick. Somehow we tricked them. Well, how did we trick them? Before we ever injected the animals, a group of researchers went up and palpated these animals and verified this is a tumor. There's one big, a renowned researcher by the name of Donald Morton, who at that time was working with the same strain, and he said, these are the animals. But when they went and said we tricked them, McGrady came to us and said, would you do it again? Well, we said we still had we had 3 ampules left. We don't have any mice left. Would you put on this? I said, well, if you bring the same strain of mouse, we'll do it. Well, he got them together with a man from the UPI, and I don't remember, and a man by the name of Cleary from the Philadelphia Inquirer. And they copied down exactly everything they said about us. They were not kind words. Then McGrady said, well, I'll tell you what, now that you've said that, let us prove it. You get the mice, we'll do it again. To which Cleary said, well, you know, it was going to be a big story, and if this works, I'm going to use your names, and I want to know why you are saying this when you know nothing about it. With that, the whole resistance disappeared, and maybe they were mistaken. We jumped forward to the New York Academy of Medicine. We did it again. And it went on. Everybody was pro and happy. Now, when you inject the animals and you put it in a table in front of all of the audience, how did we switch the mice? This is what they claimed, that we somehow switched the mice on them.
We jump forward in time. Your skeptics, your critics continued to be in positions of power to deny you research funds, to deny you an opportunity to do your work. You decided after a number of years that it was best to work in an environment where you would be less restricted by bureaucracy. So you came here to the Bahamas, to Freeport.
Well, no, there was a short stay out on Long Island.
Right.
And we left Long Island, nobody chased us. So for freedom. And also to protect the MDs. Now, I've never treated a patient, but to protect the MDs, when a patient came with a hopeless case, to protect them, we had to send that patient to surgery, radiation, and chemotherapy. And if they made it through that, they could come back and be treated with impunity at the clinic on Long Island. And some of them came back, and some of them made it. And there were still some, I think, 3 or 4 patients alive out of that original group from 1974-75. But I saw that they couldn't touch me. What do they want to do? Call me a quack and take the H out of the PhD? They can't take my license away. I have my degree. But they could, the confreres could attack those MDs. So I came to the Bahamas, went to the Bahamian government and said, I think we have something. Can we try it out for a 5-year period? For which they said one important thing, that you cannot get a salary any more than any other PhD in the Bahamas. So the salary was done, and now try it out. And to go very quickly, what happened with that, we tried it out. First of all, we knew what the dosage was. That we had learned in Long Island. But how do you give it? So for 1 year, 288 patients, and I still think there's about 30 or 40 of those still alive. That's from 1977. We learned how to give it. These are 3 proteins. If a patient makes tumor antibody, you cannot give them more antibody. I mean, it's a waste. You're unbalancing. You give them tumor complement first, which activates the antibody, just kills the tumor. When a tumor cell dies, it releases a prealbumin, a protein, which we can titer and measure whether these doses were right.
So you're measuring the effective kill ratio in the blood?
In the blood. Now, to get rid of the blocking protein, we use a deblocking protein called an alpha-2 macroglobulin.
So what you're saying is that the cancer cell protects itself by forming a protein around it.
Well, I don't know around. All I know is that any cell, when it dies, infections kill cells, the level, the titer of this blocking protein, the prealbumin, elevates. So all cells produce this, theoretically, to prevent your immune mechanism from killing those cells. Now, when a tumor cell dies, wonderful, but it does liberate that prealbumin, which prevents the further activation of the antibody by complement. At one time I said, my God, the tumor has a mind of its own. No, this is a body function. If you can theorize, it has a good function. Your sanitation department is your liver. That eliminates the byproducts of cell destruction. When you get gangrene, you don't die of the toxin. You die of too many cells. You die of liver failure. So this prealbumin, the blocking protein, the level goes up. It stops the further activation of the antibody by complement, giving your liver time to eliminate that. Now, just in the past couple of years, I've seen something else. Many cancer patients get periodic elevation of temperature. Not high, 101, it could even go to 102, and then it goes down. Theoretically, I'll theorize. This is good. What is occurring is that most enzymes work more efficiently at a slightly higher temperature. And your liver isn't getting rid of the cell debris, the temperature goes up. The enzymes work faster. But over the years, we'll capsulize this. We learned the dosage and then saw that, well, my mind couldn't keep it all. We went into computer. From one computer to another. I estimate over the years, since '78, we spent almost $1 million on hardened software. Now, this didn't come out of my pocket. There was no grants. It came from the patients. The patients are responsible for that. That's what they pay, we use to that. There was no fortunes made. Up until 1984, I hate to tell you, my total bankroll was $1,800. We kept putting it back. But now we have gotten into computerized. The computer does it better. It's insulting to a degree.